Welcome back to AI Paper Podcast. Today, we're diving into this paper that's been creating quite a buzz in the AI community. It's called On the Emergence of Thinking in LLMs, Searching for the Right Intuition. And it's by Yi et al. And if you're anything like me, always trying to push the boundaries of what TI can do, you're definitely going to want to stick around for this one.
It's definitely an exciting paper.
Yeah. For those of you just joining us for the short form edit, here's the quick rundown.
Perfect.
The paper basically explores how large language models, so LLMs, are evolving into what they call large reasoning models, or LRMs. And it's really cool because they're actually able to reason during inference.
Really interesting stuff.
Yeah, and they're proposing this new post-training framework called reinforcement learning via self-play, or RLSP. And it focuses on encouraging exploration and then also outcome verification during training.
It's like pushing the models to think outside the box,
Yeah. Exactly. And get this, they actually observed emergent behaviors like backtracking, self-correction, even exploring different ideas. And this was in models trained using RLSP, but without any explicit supervision.
So basically, they're learning to think on their own.
Yeah, pretty much. And here's the kicker. Just incentivizing the model to take more steps led to some really surprising results, but we'll get into that in a bit.
I'm excited to dig into that.
Yeah, me too. Okay, so back to the full episode. Have you had a chance to skim through the paper at all?
Yeah, definitely. And the premise is really thought-provoking. The idea that we can train LLMs to actually think by treating reasoning as a guided search. It's fascinating.
Yeah, it definitely caught my eye too. And they even draw a parallel to techniques like self-consistency and process reward modeling.
Right.
And even AlphaZero, which use a search-based approach to master Go.
Oh, yeah, I remember that.
Yeah. But instead of searching through possible moves in a game, the model here is searching through different reasoning steps to try and reach a solution. What do you think is the most innovative aspect of their approach?
That's a good question. I'd say it's got to be the RLSP framework itself.
Okay. Yeah.
It builds on some familiar concepts like, RLHF and constitutional AI, but it introduces this unique twist by decoupling the exploration reward from outcome verification.
Decoupling. Okay, you've piqued my interest. What exactly does that entail, and why is it so significant in their findings?
Okay, so imagine you're training a model to solve some math problems, right?
Okay.
Traditionally, with something like process reward modeling, you'd reward the model for steps that lead it closer to the right answer.
Right.
But with RLSP, you're also rewarding the model for exploring different reasoning paths, even if those paths don't immediately lead to the correct solution.
Oh, interesting.
Yeah, you're essentially encouraging the model to think outside the box, to try different approaches, learn from its mistakes.
That's really interesting. It's almost like saying, hey, we appreciate your creativity and effort, even if you stumble a bit along the way.
Right.
But then how do they make sure that the model ultimately learns to tell the difference between the right and wrong answers?
Right, so that's where the outcome verification comes in. They use a separate mechanism to evaluate the correctness of the final solution, making sure that the model is grounded in reality.
Gotcha.
And that decoupling, it's crucial because it lets the model freely explore different reasoning strategies without being penalized for those initial errors.
Right.
Ultimately leading to a more robust and flexible reasoning process.
So it's a delicate balance
Yeah.
between fostering that exploration and then also maintaining accuracy. I'm curious, how do they actually measure this exploration aspect? Is it based on some complex metric?
It's actually pretty straightforward. They experimented with two approaches. One is rewarding the model for generating longer responses, assuming that more steps usually means more in-depth reasoning.
Makes sense.
And the other one involves using a separate LLM. In this case, they used GPT-4 to evaluate the creativity and the reasoning effort shown in the model's response. And this is all regardless of whether the final answer is right or wrong.
Wow, using another LLM as a judge. That's pretty clever. It's like having a peer review process, but for AI thinking. So did this approach actually lead to any tangible improvements in the model's performance?
Oh, absolutely. They found that RLSP led to significant performance gains. For example, on the math dataset RLSP, boosted the llama model's performance by a whopping 23%.
Wow.
Yeah. And on the AME 2024 math problems, which are notoriously difficult, the Quinn model saw a 10% improvement, all thanks to RLSP.
Those are some significant jumps. But did they only observe better scores, or were there any noticeable changes in how the models actually approached the problems?
That's where things get really exciting. They observe these fascinating emergent behaviors in both coding and math domains, and get this even without any supervised fine-tuning.
Emergent behaviors. Okay, you gotta give me some specific examples. That sounds intriguing.
So, for instance, the model started doing things like backtracking, exploring alternative solutions, even self-correction, all during the problem-solving process. Figure 1 in the paper, it beautifully illustrates a model working through a geometry problem.
Okay.
And it starts down one path, realizes it's not working, then backtracks and tries a completely different approach.
So it's actually like reasoning.
It really seems like it.
Yeah.
It suggests that the model isn't just blindly following a set of rules, it's reasoning through the problem, adapting and adjusting its strategy as needed.
It almost sounds human. These aren't behaviors you typically associate with traditional LLMs. Did they look into what would happen if they just used pure reinforcement learning without that separate exploration reward? Would the model still develop these thinking skills?
Yeah, they did. And the results are really interesting. Pure RL, where the reward is solely based on the final answer, it didn't consistently lead to these search behaviors emerging. So it seems like that separate exploration reward, it's really crucial for guiding the model to develop these more sophisticated reasoning strategies.
So it's not just about getting the right answer. It's about the journey, the exploration, the process of thinking itself. That's quite a philosophical leap for AI.
Yeah.
Did they offer any theoretical explanation for why this exploration reward leads to such interesting emergent behavior?
They suggest that RLSP might be fostering a form of self-improvement in the models by encouraging the model to explore those different reasoning paths. It's essentially generating new chain of thought data to learn from. And this continuously refines its reasoning abilities. It's like the model is writing its own textbook based on its experiences, constantly expanding its knowledge and understanding.
That's fascinating. So the more the model thinks, the better it gets at thinking.
Yeah.
And this is all achieved with relatively small-scale experiments. Imagine the possibilities if this framework were applied to larger models and more extensive data sets.
It's definitely an exciting prospect. But before we get too carried away, let's maybe take a closer look at the limitations of this work. There are always caveats to consider, even with groundbreaking research like this.
That's a good point. No research is perfect, and understanding the limitations is just as important as celebrating the breakthroughs. Let's take a quick break, and when we come back, we'll delve into the potential drawbacks and any unanswered questions this research raises. Okay, so we're back, and before the break, we were really getting into the nitty-gritty of how this RLSP framework is kind of pushing the limits of what LLMs can do. But like you said, it's super important to consider the limitations.
Yeah.
What are some of the caveats the authors highlight in the paper?
Well, one thing they acknowledge is that their experiments were limited in scale. They worked with relatively small data sets and models, so it's not really clear if these emergent behaviors would translate well to larger, more complex models and tasks.
That makes sense. It's kind of like trying to predict the behavior of a hurricane based on just like a small gust of wind. There's a lot of complexity that could be missed. Did they mention any other constraints?
Yeah. One thing that stood out to me was their observation that while the models showed some impressive search behaviors, they weren't necessarily novel in the truest sense. They were essentially mimicking reasoning strategies that humans already use, strategies that were probably present in the training data to some extent.
So they were demonstrating thinking, but it wasn't truly original thought, more like really sophisticated imitation, which is both impressive and humbling at the same time. It makes you wonder about the nature of true creativity and whether AI can ever really achieve it.
Absolutely. It's a huge question that goes way beyond this specific paper, but it's definitely something to think about in terms of limitations. Another point they bring up is that even with these emergent search behaviors, the models didn't always get the right answer.
Oh, really?
Yeah, there were cases where they showed signs of self-correction, but still ended up with an incorrect solution.
So even thinking models can make mistakes, which I guess makes them even more human-like in a way. But seriously, why do you think that happens if they're capable of backtracking and correcting themselves? Shouldn't they always end up with the right answer?
It probably comes down to the inherent limitations of the models themselves and the data they were trained on. They might still be missing some depth of understanding or the breadth of knowledge to consistently solve really complex problems, even with that extra boost from RLSP.
It's a good reminder that we're still in the early stages of developing truly intelligent machines. There's still so much more work to do in terms of both model architecture and training data before we can really expect them to achieve human-level reasoning consistently.
Totally agreed. Now, shifting gears a bit, I think this research opens up some really cool avenues for future exploration, for example. They mostly focused on math and coding domains. Do you think this RLSP approach could be applied to other areas, maybe more creative or open-ended tasks?
That's a great question. Imagine seeing these thinking behaviors in models that are trained to analyze literature, compose music, or even design scientific experiments. The possibility is pretty mind-blowing. It would be amazing to see if this framework can unlock those more intuitive, less rigidly structured aspects of intelligence that we usually associate with human creativity. What other questions do you think this research raises?
On a more philosophical level, I think this paper really makes us confront the question of what it actually means for a machine to think. Are we just anthropomorphizing these models, projecting human qualities onto them because they're doing things that kind of look like our own cognitive processes, or is there something deeper going on?
It's a question that's been debated by philosophers and AI researchers forever. And I don't think this paper gives us a definitive answer, but it definitely adds fuel to the fire and pushes us to think harder about the nature of intelligence, both human and artificial. Any other thoughts on where this research might lead in the future?
Well, the authors themselves hint at a fascinating theoretical connection between RLSP and the idea of self-improvement in LLMs. They argue that by encouraging the model to explore all these different reasoning paths, we're essentially prompting it to create new chain of thought data that it can then learn from, leading to continuous improvement in its reasoning abilities.
It's like the model is bootstrapping its own intelligence by constantly generating new training data based on its own thought processes. That's a pretty powerful idea.
Exactly. And it raises the possibility that the more the model thinks, the better it gets at thinking, leading to this kind of virtuous cycle of cognitive development.
This is definitely one of the most thought-provoking papers we've covered on the show. We've gone through the technical details, explored the exciting results, and even considered some of the philosophical implications of this work.
And we're not done yet in the final part of our discussion. We'll shift gears and focus on the broader implications of this research. How might thinking LLMs change the world as we know it, and what challenges and opportunities are waiting for us?
Welcome back to the final part of our deep dive into this fascinating paper on the emergence of thinking in LLMs. We've really broken down this RLSP framework, explored its potential, and of course acknowledged its limitations. But now I think it's time to step back and look at the bigger picture. Like, what could thinking LLMs actually mean for the future?
Well, the implications are huge and honestly kind of mind-boggling to even think about. Imagine a world where your AI assistant can not only understand what you're asking it to do, but can actually grasp your intent. You know, like proactively suggesting solutions or even anticipating potential problems before they even pop up.
Yeah, it'd be like having a colleague who can not only just execute tasks, but can actually brainstorm with you, challenge your assumptions, offer a fresh perspective. That kind of AI collaboration could totally revolutionize so many fields, from scientific research to even creative endeavors.
Exactly. Think about AI systems that could design experiments, analyze complex data, generate hypotheses, and basically accelerate the pace of scientific discovery, or AI, that can help us tackle these huge societal challenges like climate change or poverty, you know, by modeling these intricate scenarios and proposing solutions that we haven't even thought of.
Yeah, those are some high-impact possibilities, but they also come with a lot of responsibility, right? If we're creating AI that can seemingly think for itself, how do we make sure it's aligned with human values and operates ethically?
That's the million-dollar question, and it's one we need to be addressing. Like right now, as AI keeps getting more advanced, we have to prioritize those ethical considerations. We need strong frameworks for AI governance, ensuring transparency, accountability, and human oversight in how these systems are developed and used, especially as they become more and more powerful.
It's a tricky balance, isn't it? Between fostering that innovation but also safeguarding humanity's interests. We can't let the pursuit of technological advancement just run away from our ethical considerations. And another thing that comes to mind is the potential impact on jobs. Like, if AI can do tasks that currently need human intelligence, what happens to those jobs? What happens to the economy?
Yeah, that's a valid concern for sure, and it needs careful thought and planning. While some jobs might become automated, history shows that technological advances usually create new industries and career paths too. I think we need to focus on education and training programs that help people develop the skills they need to thrive in this new landscape, emphasizing things like critical thinking, creativity, emotional intelligence, you know, skills that work alongside AI, not compete with it.
I think adaptability and lifelong learning are going to be key in this future, where humans and thinking machines work together. This research has brought up so many profound questions, and it's clear that we're really just at the beginning of a very exciting and potentially challenging journey.
Absolutely. This paper is just a glimpse into the huge potential and responsibility that comes with developing AI that can seemingly think it's a call to action for researchers, policymakers, and really all of us to think critically, have those tough conversations, and take proactive steps to shape the future of AI in a way that's both ethical and responsible.
And to all of you listening, we highly encourage you to check out the full paper and the code, which is on GitHub. Explore these concepts, challenge your own assumptions, and join the conversation about the future of thinking machines. Thanks for joining us on this incredible deep dive. We'll be back soon with more explorations into the cutting edge of AI research. Until then, keep thinking, keep learning, and keep pushing the boundaries of what's possible.